Thank you so much, Cassandra. Appreciate the introduction there. Well, hello, everyone, and welcome to our inaugural Data Forums. My name is Alison Krepp, and I lead the Social Science Program in the Weather Program Office of NOAA's Office of Oceanic and Atmospheric Research, also known as NOAA Research. And a big thanks to the library for hosting us today. We developed the Data Forums to meet a need in the extreme weather, social, behavioral, and economic science, or SBES community. The rapid pace of technology is creating powerful opportunities for researchers to leverage data, particularly societal data, in ways not possible or easily accomplished even 5 years ago. There's a need for peer-based networks, data norms, and infrastructure to support and guide this transformative moment. These data forums are a new form of community engagement for our program, and we've designed them around these needs. And we're excited to create and build this space with you. We want to note that we intentionally chose to describe these as forums rather than trainings or workshops because our intention is not to teach you today. There are courses for that, and this is not a course. What we do want to do is increase your familiarity, and by doing this, motivate your engagement with metadata, data exploration, and data integration, using demonstration, connecting you with resources, and, as the name implies, providing a forum to begin and foster further dialogue among the growing extreme weather SBES community. We estimate that there's between 70 and 90 of you out there today, and we're going to share a little bit about what we know about who's who in the audience, as that's not always obvious in Vimeo land. So in today's audience, we have a mix of NOAA and non-NOAA attendees tuning in from around 12 states and beyond, as well as a number of time zones represented as well. So good morning, good afternoon, good evening, wherever it is you may be, and we're glad you're here. This also gives us a chance to test out the chat function that Cassandra was talking about. So if you would, go ahead and put in chat the state that you are joining us from, and we'll see how that works out for us. We also wanted to give you a sense of the research areas that are represented here today with this slide. And this is a good illustration of what excites me most about what we are kicking off with these forums. Looking at what's on the screen, if we think about the connectivity and interoperability that could be made possible with enhanced metadata and increased data integration capabilities, it's inspiring. And we're excited to have the opportunity to do this collaboratively as a community with those of you joining us. Another thing we know about the audience is we know that most of you are mixed methods researchers, but that's not all that we have out there. We do know that there's a good contingent of qualitative and quantitative researchers out there as well. So thank you for joining us. And then lastly, let's move to the next slide. If you thought you might be here with a bunch of Python experts, I put this up to show you that many of us today, and I count myself in this, sit on the minimal to no prior Python experience side of things. And we're very happy about that because the data forums are designed to pull back the curtain in an approachable way for the SBES community to engage with metadata schema and data integration and get a sense of what these look like, how they operate, and the opportunities that they represent. Now that you have some understanding of who you're in the virtual room with, I want to introduce Kyle Metta. He is leading today's forum, and Kyle is a computational social scientist and serves as the SBES Data Integration and Partnership Analyst with our social science program, where his primary focus is working on our Societal Data Insights initiative. I do want to stress that this is a new format for us, so we're glad that you're coming with us on this journey. Cassandra covered using the chat for questions, and I also want to note for folks out there that John Mote, who will be on the main stage tomorrow with the second forum, will be moderating that chat. So if you need help or want to ask a question, please know that you'll find John there to be able to provide you with some assistance. I think the last note before I transfer it over to Kyle is the GitHub page, which I think many of you visited yesterday, looking at the numbers for that particular page, and we're glad that you did. That serves as the base camp for the forums. So I think, John, you'll put that in the chat if you haven't already, so that folks have easy access to that resource. And with that, I'm really happy to turn it over to Kyle to kick off our forums.
Great, thanks, Alison. Super happy to be here today, and thanks for everyone for coming. Today we're going to talk about metadata, but not in an abstract or technical sense. We're going to ask, how does metadata, or the lack of it, shape our ability to do good science? And here's the path that we're going to take. First, we're going to experience this problem together by looking at a data set that seems promising, but is maybe missing some key context. Then we'll explore why this problem keeps showing up in our fields. After that, we're going to show a test and test a draft solution, the schema that we've been working on, and we'll end up by stepping back to think about how this work might evolve across the broader community. And again, we're not trying to arrive at a final answer today. It's about beginning a conversation and exploring possibilities that could grow over time. Before we dive in, I want to set the stage a little bit. We want to acknowledge that folks joining us today are at very different points in their data journey. Some of you have been working with metadata standards for years. Others may have only encountered metadata when you're uploading it to a file to a repository or filling out a grant template. So here's how we're going to approach this. The goal is to have a shared starting point, build a common language that we can use to have a conversation together. Some of this may feel rather basic, some might feel more advanced, and either of those is okay. The point isn't to make anyone an expert today, but to get us aligned enough to talk meaningfully as a group. Alison already pointed this out, but I want to also hit it, is that a little note on methodologies. Most of the examples you'll see today and tomorrow are rooted in quantitative social science, surveys, structured data sets, statistical analyses. But the principles we're talking about, things like documenting your research context, clarifying geography, time periods, or explaining your methods, these are just as relevant for our qualitative or mixed methods research colleagues. So if your work looks different from these examples, the principle should still apply. And so again, we're just thinking about this as the beginning of a conversation, not the final word. Our hope is that this forum creates the space for deeper dialogue about what metadata should look like for our community, across these different traditions, different methods, and different disciplines. Now let's do a quick reality check. So I think the truth is most of us don't wake up in the morning excited to write metadata, right? We're focused on getting the science done. We want to design the study, collect the data, run some fancy analysis, and write that paper and send it off to nature and become famous. And metadata often comes in at the very end when you're already feeling the pressure of the journal editor yelling at you, or the funder requiring this at some point. And that's the tension we're dealing with, right? Metadata can feel like an afterthought, a compliance burden. But in practice, it is the core part of making research outputs useful. Without it, even the best data sets risk becoming orphaned. No one else can find them, or if they do, they can't find out how to use them. Another reality, if you start to audit some of the data sets around our community, is they don't come with the context you'd actually need to reuse them. You might find a file on a colleague's hard drive or somewhere off in a repository, but without knowing, which storm event or the specific geography or the methods, or even what some of the variables means, it's almost impossible to tell if it's relevant. So this forum is about facing that reality honestly. We're not here to pretend metadata is easy or glamorous. We're here to show why it matters and explore together how to make it easier, lighter, and more useful in practice. So let's take another minute to make this real, and I want you to do a quick self-check. Think about these situations. You spend hours hunting for the perfect data set, something that's going to help you answer some research questions, but nothing is quite fitting. Or you finally find that right paper or data set, but the data is behind some locked door, or is described in a way so poorly that you can't really use it. Or maybe you've been frustrated by unclear methods or missing details. And then if we were to flip that around, how many of us have published a paper where the data you collected never quite got documented the way you intended? I'm very guilty of this. Maybe you thought, I'll clean it up later, or maybe you weren't sure how to share it responsibly, or how to align it with what your IRB said. So here's what I'd like us to do. Let's add up, just from this list, how many of these ring true for you. Could be 0, could be 2, could be all the way up to 6, and just drop that number in the chat. We don't need to overthink it. This isn't about judgment. It's just seeing how common these experiences really are. Seen some 6s, some 5s and 4s. I think I'd put myself at a 5.5, potentially. Lots of 4s. And that's what we would expect, right? Because almost all of us have been on both sides, right? We know what it's like to need better metadata, and we also know how hard it is to make it. And that's the paradox. Wanting good metadata, but struggling to produce it is exactly what we're trying to explore today. Thank you all for putting that in the chat. And I want to talk about why metadata might often feel like a tragedy of the commons. My training is in common pool resource management a little bit, and so I still think about it this way. And it's a situation where we all benefit when the data is well documented, but very few of us feel like we have the time or incentive to actually do it. So on the left here, we have the problem, right? Everyone benefits from well-documented data. We all suffer when data is poorly documented. But in practice, documentation feels like overhead, right? It feels like time we're spending not doing real research. On the right, the cost of that mindset, right? Without good metadata, we duplicate data efforts. We can miss opportunities for collaboration, and we can slow down scientific progress and reduce the potential impact of our research. And these are the collective costs that grow over time. This cartoon, generated by Gemini, captures this paradox, I think, quite well. Each individual is acting rationally. If only these people would take the bus, traffic would be fine. But since everyone thinks that way, the system as a whole breaks down. Metadata is the same, right? If we all think someone else will document, the collective outcome is dysfunction. So again, this is why we're here today. Everyone wants good metadata when they need it. No one wants to create it. And our goal in this forum is to start shifting that dynamic by building shared standards and practices and norms and make metadata less of a burden and more of a benefit. And in the backdrop here is really open science. And sometimes that term gets thrown around loosely. I particularly like this UNESCO definition of open science being a set of practices that make scientific knowledge openly available, accessible, and reusable by everyone. And that doesn't just mean putting your data in a folder somewhere online, right? It means ensuring that others, now or years from now, can actually use it. And that's where metadata fits in, right? Metadata is what makes data open and usable. So when we're talking about metadata, we're not talking about extra bureaucracy. We're talking about the infrastructure of open science, the things that make our data findable, interpretable, and reusable in practice. But why does this matter for us in social science weather research? I think we take a step back and start thinking about the research questions people are asking. Things about evacuation, risk perceptions, community responses. These questions, they don't live in isolation, right? They often need to be connected to physical science data like storm tracks or flood maps. And they often benefit from being compared across different communities or across events with different intensities. And so integration is only possible when metadata is there. Without it, each data set sits on an island. And with it, we can connect our work into something larger and maybe more impactful. Well, let's be honest. The system is only going to work if metadata has value for you, not just for the commons, right? So what's in it for you as a researcher? I think the first can be really lumped into time savings. Metadata is your future self's best friend. How many times have you opened an old data set and thought, oh, what does this variable even mean? How did I actually transpose this? What was I doing here? We can also think about career benefits, right? So the clear documentation of your data can support grant renewals, replication packages, and maybe even boost your citation counts by making yourself more visible. And then there's the impact of our research, where metadata can expands the reach of your work. It enables secondary analysis. It can lead to new publications and collaborations. And the point here just being that metadata isn't just altruism, right? It's not just that you're a good person, so you're contributing to this. It's a way of amplifying your own research impact. So here's today's mission. We're going to experience both sides of that tragedy of the commons. First, we'll try to make sense of a data set with no metadata and feel that frustration again, so we're all on the same page. And then we're going to add in basic metadata, which most people commonly provide, and see how that changes the picture. And then finally, we're going to look at what a comprehensive metadata form would look like and see how that changes the perspective on this data entirely. Along the way, we're going to introduce some tools that you can use, things like Jupyter notebooks and GitHub accounts and JSON files. But don't worry if any of those are new. We're going to explain what they are, why they matter, and how to use them. And the goal here isn't just to talk for 70 minutes about schemas. It's to walk you through the lived experience of what metadata can make possible. So I mentioned we're going to be using some tools today, and there's a variety of ways to use those, and I'll go over those more in more detail in a minute. But again, we're going to use the chat for any open forum questions, and then we're going to be using notebooks to go through some data. So let's talk about notebooks. When we say notebook, we don't mean the paper kind, though that's kind of a useful metaphor. So a notebook is an interactive document that brings together text, code, and outputs all in one place. We can think of it as a lab notebook for data science. You can write down your methods, run the actual analyses, and then immediately show those results all in one document. And that makes it both transparent, right? Because you can see exactly what happened, but also super reproducible. You can just rerun that notebook. So you're not just sharing conclusions, you're showing the full path you took to get there. I think that's why notebooks are so powerful. They make analysis step by step and transparent. They make research easy to share and reproduce. And they serve as that bridge between plain language explanations and the machine executable code. So now that we know what a notebook is, let's zoom in on how they actually work. So a notebook is made up of pieces. These pieces are called cells. And you can think of those cells as building blocks. Each one has a different job, but they kind of stack on top of each other. And there are three-ish main types of cells you'll see today. First are markdown cells. And these are just for writing, just for text. Use these for your notes, explanations, maybe citations. That's how we tell our story around data. Today, that's where our instructions and context is going to be. Then there are code cells, and these are where the action happens. This is where little chunks of Python or R code will exist to load data, to run analyses, or create visualizations. And then finally, we have output cells. And so every time you run a code cell, the result shows up right below it. And that could be a table, a chart, or even a model. So again, in one document, you're getting your narrative, your instructions, the actual analysis, and the results. And you also notice we're using Python here. Alison mentioned that earlier. And Python is one of the most widely used programming languages in science, data analysis, largely in machine learning. And it's popular because it's very relatively easy to read and also write. And there's a huge ecosystem of tools for statistics, for visualization, for data wrangling, and it's rapidly becoming the language of modern data science and statistics. So you don't need to know Python to follow along today. We're using it behind the scenes to power the demonstration. You'll see little code snippets, but think of them as the machinery that lets us open data sets, calculate things like sample size, display tables or charts. And the point today is not to teach you Python. There's plenty of opportunities for you to learn, and some of you are pretty familiar. The point is to show you how notebooks powered by tools like Python can let us make metadata and integration challenges visible and concrete. And because we know everyone has different comfort levels with technology and different learning styles, we've made the notebooks accessible in 4 ways. So you can just follow along in the rendered HTML. So if you're on one screen and you just want to watch me go through it or read along in HTML, super simple way to do that. There's no software. Otherwise, you can launch them interactively with Binder, and I'll show you how to do that. And if you're in the Google environment, you can use a Google Colab. If you're super advanced and want to run this in your own local Python or R environment of your choice, we've also provided download links for that. So I'm going to transition to the link that was shared earlier to our GitHub page. So you probably all started on this tab right here. And what we're looking for is to move over to the left-hand column here and go down to Forum 1. And in here, you'll see the overview of what we're talking about today. And then you have 2 links to launch this notebook. You can either launch it in Binder or in Google Colab. I'm going to go ahead and try the Binder. If a lot of us try to do this at once, it might not work. And it might take a minute. But I'd also like to say, if you're, again, a person that's maybe on a tiny screen and you'd rather just watch a demonstration, I'm going to be going through everything. So if that's easier for you, feel free to just watch the video. So here we're just describing what we're going to be working on today. And I just want to note that all of the data that we're going to be talking about and going through, this is all synthetic, right? Here we've created some data sets for exploration and demonstration purposes. This isn't real data. This isn't real respondent data. There's nothing sensitive here, so we can really dive in. The steps we're going to do today, we're going to describe our own data sets in some plain language. We're then going to inherit this mystery data set, try to figure out, what's the feasibility of integrating it with our own data. And then we're going to look at some metadata and see how that helps us put the pieces together. Before we get started with that, so this is our Jupyter notebook again. This is our first cell, which is a markdown cell. And it's the one we're in is because you can see this blue bar. And that means that that's the one we're in. If you wanted to, let's say, go down to this one, you see that the blue bar changes and we're in this. And now if we wanted to run this cell, you can go Shift Enter. And we saw that there was a little blank right here, which said that Python was thinking. And what we did here is we just imported a few packages, also sometimes called libraries. And these are just pre-written collections of code that give us tools for data loading, cleaning, and display, so we don't have to reinvent the wheel. Today we're only using very simple ones. One is pandas for working with tabular data, things like spreadsheets. And this other one here is just to be able to show some of our outputs in a more pretty way with Markdown. So our first kind of activity is to think about a data set that you have. And let's imagine that somebody has approached you to use this data set for something else. And I know when you've had maybe a graduate student or a postdoc or somebody, a collaborator, and they say, oh, can I use that data for this thing? Me personally, I get a little bit of anxiety, like, oh, there's so much about this data, so much context that I need to be able to communicate to you so that you can use this responsibly. So I want to put yourselves in that situation and take 3 to 5 minutes to kind of write down what you would want to tell them. Imagine that they are also a scientist. They know some of your work, but they're not super familiar with your methods or what this data set actually is. Focus on that context, the geography, potentially the time, the methods, the sample sizes, and variables. Write that up, and then we will share a few responses in the chat if you'd like. I see some of us are still getting settled into Binder, so I'll give us some extra time here. If you're getting the Binder too many users, you can try to refresh that, or you can just move over to the Google Colab version of the notebook, and that should open up for you. And again, for those who are just getting settled into the notebook, reading the context, we're just imagining that a colleague wanted to use some of our data, and we were thinking about what kind of information, what kind of context would we provide them to be able to use it responsibly. Does anyone want to share it in the chat? What kind of context they would provide? Well, continue to feel like you can add that to the chat if you'd like. I want us to reflect on what that is, what that activity is. What we're describing your data set in plain words, right? We're really creating the metadata or the context for our data. And we can think about that as unstructured metadata, right? That's free text, super useful for humans, people like me, to read it, but it's hard for machines to parse and connect, right? So later in this session, we're going to talk about how to make this same information structured using a schema, which is just a standardized set of fields like a title, creator, date, location. And it just ensures that everyone is describing data in a consistent way. When we start talking about structured metadata, it's both human readable and machine readable, which makes it possible to share, discover, integrate, and reuse that data more consistently. So now that we've done that, right? We thought about our own data. We're going to move into exercise 2. In exercise 2, you're going to put on a different hat. You're going to think about yourself as a researcher who has just done a study, and your study was an evacuation survey for Hurricane Idalia. You got a really nice sample size of 892 participants. You've done your analysis, you've done a study, maybe you're at a conference and someone's like, oh, it would be really interesting if you could do some higher level, HLM modeling or some multi-level modeling, but to do so, you would need some higher statistical power. So you would need about 2,000 respondents. And you want to be able to compare evacuation timing across different time and events. But then you get this email from a colleague who attaches a CSV file and says, hey, I think this is going to work for your evacuation research. And so now you have a task, and that task is to figure out, do the variables line up, right? Is this going to work for us? Is there a geographic linkage that we can say that this is around the same area? Did they use a similar methodology to you, which was a household survey? And is there a temporal alignment, right? Did this happen around the same time for a hurricane? Is it comparable and what we can see from that. So our first step here is to open this data set. Right? So we have this CSV file and we want to be able to open it. So we're going to open it in Python, and then we're going to look at the basic overview. How many observations do we think it has? Let's explore those variables. Let's see what those variable names are, and see what the first few sets of observations look like. So here we have some very simple code where we just point at this CSV that is on our GitHub page. Here we turn it into tabular data, so we read it into pandas. And then we're going to just do some really simple stuff here, which is, hey, what is the length of that data? Meaning, how many observations are there in it? Would this hit our 2000 threshold if we were to add it to what we already have? And then what are the variable names? And so if you click into this cell, and again, Shift Enter, it will very quickly run and start to answer some of our questions. So here we think that there's around 1,200 new observations, bringing our sample to 2139, and that there are 15 variables within this data, meaning columns. And then here is just our first couple observations within this data set. So now your task is to run that code and look around a little bit here and see, does anything look familiar or useful for our study? What's still unclear? Which of these variables might be interesting to use? And then in the chat, we will ask, what do you first notice? Do we think this is a good contender? All right, so maybe you're looking at this and you're reading the variable names and you're like, oh yeah, some of my research is interested in how social networks inform how people make decisions. We're looking through here, we have some encoded data for income level and some age group that's also encoded. We're looking through it. We know that there's some social media use. This might be useful for us. We know that we have dates, which is useful, because that's something that we're going to care about. And it looks like we have zip code data, and potentially this could work for our data set. So if we move on to step 2, one of the first questions we might want to ask is, where were these data sets collected in the same place, right? So for evacuation research, a lot of you are bigger experts on this than me, would imagine that geographic coverage is critical. So if the survey locations overlap with our Sarasota County, integration might be possible there. And if not, the data sets might not be directly comparable. We might have to have a different study design. We can still explore this data, but maybe not in the way that we wanted. So for this next cell, we're going to do something very similar to the first one. We're going to look at that column of data that had the zip codes, and we want to look at for most common locations, right? So we're going to create a quick histogram or frequency table of those zip codes. We're going to look at those zip codes and see if they line up with our study, or do they point somewhere else. So again, we're going to put in some very simple code here, which just says, look for unique zip codes within that column. We're going to combine those into a dictionary and then count how many of them for each zip code so that we can see that frequency. So again, we could run this with Shift Enter, and we start to see that we have some zip codes. We have 78 zip codes. We see a quick distribution of those zip codes, of observations in those zip codes, and we see some of these as a sample. So now just looking at these zip codes, does anyone know where this data set's collected? Is anyone more familiar with Florida? Do these overlap with Sarasota County? Can we determine anything from just looking at these zip codes? And you can put that in the chat. So someone says Lee County. Interesting. I like that. So right, you probably have some experiential knowledge of Florida to be able to do that, or maybe your research hits here. But still, it's almost like a fishing game here. We're not really sure where this is, right? We could do some lookups to add to this. You're from that area, perfect. Right, but that's the kind of context you would need to have to be able to determine just from looking at these zip codes if it's the right place. And yes, we can make a quick map and try to see where they are, but right now we're just trying to determine if we want to use this data. So just on that, does anyone feel confident, just based on that information alone, that we could integrate? Why or why not? Someone Googled it, perfect. Any other thoughts here? All right, so for me, I think we're moving in the right direction, especially with all of your help in the chat. We know that this has something to do with Florida, so perfect. Our next big question is evaluating, when was this data collected? Was it in the same time period? Is it comparable? Was it years ago? we need to figure that out, right? So if the two surveys measure evacuation behavior during the same storm, hey, that's going to inform our design here. Is it the same season? They're probably more directly comparable. If they're different years, different storms, hey, we might have to think about those complexities, but maybe it informs a pretty cool design. So again, we're going to do the same thing. We're going to run the code below, and we're going to compare what we know about our Sarasota study from what we can find out. So this code, again, we're doing very simple stuff. We're looking at the survey date minimum and the survey date maximum, so we can see the time span. And then we're just going to look at the distribution of those dates with observations. So again, shift and enter. And we're finding out that this was collected over a 2-day time period. We have the earliest date, it looks like September 28th to the 30th. And then we see that there is almost equal amounts of distribution over those 3 days. That's what I see, at least. And again, this is outside of my expertise, so hopefully someone in the chat knows. Do we know what storm or event this data set could capture? Right, so this was in 2022. Our data is from 23. Someone thinks it might be Hurricane Ian. Interesting. Could be. Can we infer anything else? Now all of a sudden it's over 3 days. I wonder, is this a pre-post event survey or a pre-survey when something hit landfall? We're actually not too sure. So as we're exploring that, notice that we started to look at the variables in the rows. We're looking at geographic coverage. We're looking at those survey dates. How are we feeling about data integration here? Andrea is on top of it. Thinks this is probably a post survey. Superb. So this is giving us a taste for something that I think a lot of us have done when you try to open a data set, is that you can try to figure out the metadata, right? You can dive in, try to understand context, try to understand when it was collected and how it was collected just by looking at the data. But that's a lot of this was we're going to be left guessing. So we could have maybe found Andrea and said, Andrea, can you look at this data with me? You understand this so well, maybe you could put it in context. Without an Andrea and without good metadata, we are left not being able to answer some basic questions about whether integration is feasible. But we do know that each one of these steps, and we could continue, gives us a little bit of information. But we still don't know specifically which storm this really represents, right? We don't know what the methods or even who collected it. We don't know if it's safe to even compare these storms or places. And it shows the limits of just working with just a file and no structured context. So now we're going to change the scenario slightly. And we're going to say, after our 20 minutes of exploring, and you can see how you could dive into that and start Googling all of these things, what would some simple metadata do for us, and would it make the difference? So now in our scenario, we notice that our colleague's email, within that email, there was also another file. It was a JSON file that was also attached. So what is a JSON? This is a JavaScript object notation, right? So this is just a simple text file. It sounds fancy, but it's just a text file for storing structured information as key value pairs. And so the reason to use this is that it's very human readable. You can see what's in this file, but it's also machine readable, right? Python, R, and most software can parse a JSON directly. And it's the standard way that metadata is stored and shared across platforms. So in practice, this is how metadata standards like DataCite, schema, etc. That are written here are usually published. So let's look at it real quickly. This is actually creating that JSON file, but you see that you have the key, so title, and then the value of that says, Hurricane Ian evacuation behavior survey. So if we run this will just clean it up so we can read it a little easier. And we see that we have some metadata for this data set. Give you all a chance to do that. So with just these few fields, which are the most commonly filled out fields in metadata for this community, we understand now what storm it is, and we know the location, Lee County. Andrea was on top of it on both accounts. And we know that we actually have a dated time, right, from the 28th to the 2nd, which is interesting so maybe our min-max didn't work properly. Who knows? Maybe we're actually missing some of the data. It's an interesting clue. And this gets us closer to deciding if integration is possible. So now with just this additional information in this context, how do we feel in the chat about integration potential? Are we feeling high, medium, or low? Andrew's feeling medium. Very optimistic. I like it. There's early convergence in the chat on around medium. Path dependency and peer pressure. I like it. So as you're still considering that, what's still missing? What information would you still wish you had so you can make a more confident decision? Andrew says, how do they choose their household sample? Super important, right? So was this other data set just a convenient sample while you had a really nice strategy? More about the sample and respondents. I like that, right? We could start making big inferences about what these demographics are, and they could be very strange. John wants to know the actual location of the respondents beyond the zip code. It's interesting. I like that. So I know I'd want some other things, right? I don't even know if there's an embargo on this data. Is it actually open? Can I use it? Is someone going to get really mad at me for it? Whose data is it? Before we start investing more resources into uncovering this, what's going on with the data? Appreciate you all in the chat. So I think when we think about the regular metadata that we were able to open, it didn't change the picture a lot. A lot of you said medium. I would agree. Like it cleared some things up, but it didn't really make it ready to do integration. So now I want to explore what it would be like if we had all of these critical pieces that people were mentioning in the chat, right? We want to know who collected it, what was that methodology, how does the sample work, are there ways to technically integrate it with maybe storm data, and importantly, I think who can we contact? And so this is where comprehensive metadata comes in, right? So instead of just a few fields, let's look at the structured schema that captures all of the details needed for confident integration. So here we're, again, producing this JSON file in this cell, and we're adding a lot more information in here, right? You also see why a JSON file is really interesting, because you can also have a dictionary inside a dictionary, so another key value pair within it. But let's run this cell to put it into our work. And then this next one is just, hey, let's print it so it looks prettier. And now we're getting some nice information, right? Hope everyone's checking this out. We have a longer abstract that says this is a synthetic data set of household data examining evacuation timing, transportation choices, and destination decisions using Hurricane Ian, not for real use. That's important. We also have their purpose, right? They're trying to quantify drivers of evacuation to inform emergency management. We have the creator. We know it's Dr. Jennifer A. Example from Florida Example University, who probably can answer a lot of questions about how to use this data. Maybe they're a cool collaborator that we want to speak to, or maybe we already know them, right? We also know that it has a unique identifier, and we're starting to get more specific in here, right? We know that this was a event-based survey within a 72-hour window. We know that there's also some additional information on spatial tracks. We know where this was. We know the coordinate system they're using. We found out that they used a stratified random sample, right, with a door-to-door follow-up, that there are some sample weights. And continuing, we see that there's a data access URL. So like maybe we don't have the full data set. We just have that CSV, but we could go to this link and get the full data set. And we also see that there's open access on this data. So we can start doing our analyses. And then again, we have our contact information. So I want us all to look at that for a minute and think about what we gained with this comprehensive metadata, and ask, which of these feels the most valuable to you in your research, and which ones would you want from colleagues if you were trying to reuse their data set. So Jocelyn said that she'd love to see the use cases spelled out, and that's pretty rare in her experience. I would agree on that one. That one's an interesting one. So in this metadata, they had use cases as evacuation planning, infrastructure risk assessments, public risk communication. Andrew is echoing that the creator is so important. I would echo that. Anyone else? Jay says that there's still a few undefined acronyms. Absolutely true in the comprehensive metadata, though it is obviously really helpful overall. I like that. Andrea is pointing to the data access URL. It could help me find references to other researchers that have used that data. Right. And what kind of manipulations do they need to do to be able to use it? John's pointing to supporting materials. Is there an instrument available at that repository, right? So is it linked to a bunch of different researchers and papers and citations? Are there instruments? Has that instrument been validated in another study? It's awesome. Fantastic. So now we should take a minute to reflect, what did we gain? We got that identification stuff that we all wanted. We got some more information about geographic and temporal coverage. We sort of understand their methodology a little bit, but it's pointing to maybe that there's some additional files or context that we'd like. There's also the integration guidance, right? Links to FEMA, links to census, links to NOAA, and then of course that contact information. And with this kind of information, now we can quickly assess whether we should be investing more time and energy into this data set. So this next cell really just makes us a nice table where we say, what are the dimensions we cared about for our data? Here's our study and the mystery data set, and then we can quickly assess, right? Just to demonstrate that with good metadata that's consistent, we could quickly find out, is this worth our time and effort? Any thoughts there? Cool. So wrapping up this section, right? Without metadata, we could spend, it says 20 minutes in your notebook, but I think you could spend endless amounts of time exploring and trying to figure out what the geography, the time, and the methods are. And I think a lot of people, especially doing secondary analysis, probably spend a lot of time doing that, right? We then saw with the basic metadata, the things that we're kind of obligated to fill out, you could identify some important features. We understood what the storm was. We understood the location a little bit better, but there were still so many missing key details. Then we saw that with the comprehensive metadata, we could confidently assess the feasibility of at least assigning somebody or spending more time on this data to see if it would work for us. We got the geography, we got the time, we got the methods, and we knew that we would have enough statistical power from our power analysis to continue doing this. And so I think the takeaway, at least for me here, is that metadata is not the overhead. It is, again, that bridge between data sets. It turns those raw files into reusable resources. So we're going to take a break now for 10 minutes. When we get back, we're going to talk about, what was that metadata, the comprehensive metadata? What was that schema? How is it created? How do those fields map directly to the problems that we just experienced? And discuss, how as a community we can refine and use these in practice. So we're going to take that 10-minute break. And when you return, and on your break, reflect on what barriers do you see to writing good metadata. Welcome back, everyone. I really hope you were taking advantage of the dancing opportunity in the break. So what we'd love to see in the chat now, that you had some time to reflect, is what barriers do you see to writing good metadata? And that can be from your experience of reading other people's metadata and seeing why it may have been challenging for them, or your own. John Mote says time. Absolutely. My experience with that is like I said earlier, it's right up to the last moment. When it's required is when you fill it out, and sometimes you don't have the time to be thoughtful on it. John is also mentioning his attention span. I feel that one as well. Not knowing exactly who's going to be using the data set. I think that one is so important, especially when we think about writing metadata for the future. So you might have a data set today that you're like, oh, no one's really going to use this. It was such a specific use case. And then what in 30 years people want to see a trend over time, right? And imagining what someone in the future might need is super difficult. I like that example. Any others? Well, feel free to keep adding those to the chat if you'd like. Knowing what is good for metadata. Absolutely. That kind of teases us up right here. So if we remember at the start, I tried to frame this as a kind of tragedy of the commons. And now you've seen it in action, right? So we can't integrate the data set because the metadata just isn't there. So I guess the question is, why does this problem keep showing up? Why does it persist? And we can hypothesize a few reasons, and in the literature it kind of helps us here. And one is that there's this mismatch of cost and benefits. And John was kind of talking about this with time, attention span, and resources, right? For the individual researcher, writing good metadata feels like extra work with very little personal payoff. But collectively, it's a huge benefit. Another reason is inconsistent norms, right? So what counts as good that we saw in the chat? Some disciplines have strong metadata cultures, right? If you think about the omics community, right? They run circles around us. There's not so much. So without shared expectations, the defaults can often slide to do as little as possible. And then there are the barriers, right? So metadata can feel technical or hard to do right. And then you can stop people before they even start, right? You're like, oh, the paralysis of not knowing how to do this correctly. And I think finally there's this feedback problem. So even if you put in the effort, you rarely hear how metadata helps someone else. That makes it harder to keep investing, right? And so what can we do about it? Again, the literature kind of provides us a few pathways. One is building shared norms so that this just becomes part of how research is done, right? We can also lower the barriers. We can do that with defined schemas, templates, and automation. And then I think there's the showing the collective benefit, right? Make it visible how good metadata makes integration, reuse, and impact possible. And that's the spirit we're bringing to these tools, right? We're not trying to reinvent metadata, but it's about lowering barriers and embedding shared norms in a way that makes the collective benefits more visible. So after laying out that tragedy, the common problem, the question is, what's our first step in trying to approach it? And so the first way we're tackling it is by developing a metadata schema for you and our community to use, to test, and to iterate on. And just to pause here again, just to nail it, schema is a funny word, but it just means, a structured recipe. It says, take these fields everyone should fill out, and here's how to do it in a consistent way. And that consistency is what lets your data set, talk to someone else's. The first thing to say here is that we didn't reinvent metadata. Metadata standards have been around for decades, and there are some really, really strong ones out there already. For example, the Data Documentation Initiative, or DDI, is widely used in social sciences, especially in survey data. Our geographers are probably very familiar with ISO 19115, right? Our go-to geographic data metadata standard. Things like DataCite provide standards for data citation, identifiers. And then obviously a lot of us have domain expertise, folks working in emergency management, weather communication, to make sure that these things can be grounded in the realities of our field. So the question, I guess, is, what is our contribution? And it's a couple things. So first, we crosswalked those known standards so that social science weather research could line up with them instead of being siloed. Then we translated that technical jargon, right, into plain researcher language. Because if people can actually fill out the fields, the standards won't get used. And then we added some specialized fields, and some of them came up when we were looking at the notebook, right? Things like decision support, use context, or integration guidance, because they don't always show up in traditional standards, but are essential for a lot of the work that we're doing. And so we should be super honest here. We're still in the testing it phase, right? We've interviewed some colleagues, walked through some case studies, and listened for pain points, but this is still very much early stage and iterative. And if you're interested or excited by this is the open door, right, to be part of that process. And this graphic shows that workflow, right, taking those existing standards that are awesome, and we align those with what we're trying to do and simplify, and then translate those into plain language. But the real key is community testing, right? Running use cases, refining fields, and building shared ownership. So that's the vision, right? A schema that can be both technically aligned with broader standards and practically usable in our research community. Not perfect, never finished, probably, but a shared starting point where we can improve together. So what does this schema actually look like? So we broke it into 7 sections to make sure we cover the full research lifecycle in a systematic way. The first 3 sections are about discovery and assessment, pretty standard things like, the title, who created the data set, what are some known keywords, what's the geography and the time period. And then we moved it into methodology and quality of the data. And this is where researchers can start to describe, how the data were collected, what pre-processing, what processing was done to the data, what uncertainties exist, what is known. And then after that, we have these specialized contributions, right? Fields for decision support attributes and community engagement. These are things that didn't exist in existing standards, but came directly from the needs of this community. And so finally, we wrap up the schema with access and collaboration, pre-standard things that are also often missing. Details like URLs, formats, restrictions, so important who to contact. And so the structure is comprehensive, but it's also organized in a way that hopefully people can actually use. Here's that same structure, but in a more visual form. You can see how the schema moves from discovery to methods, to decision support, and then to community engagement ethics. Each box here represents a group of fields. For example, identification and overview has 10, subject classification has 6, geographic and temporal has 8, and so on. The takeaway here isn't those exact numbers, right? It's that coverage. We wanted to make sure that nothing critical was left out, but also not overwhelming researchers with unnecessary burden and detail. So we can think of this as a scaffold, something to guide good practice while still leaving room for flexibility. So we talked about the schema, but let's be real. Writing metadata from scratch can still feel overwhelming. So what we're trying to do now is make it practical. That means lowering the barriers and giving people tools, templates, and examples that make it easier to get started. So some of these are already underway, and some of them are things that we hope to co-develop with folks in the community. For example, we're starting with automation tools, a simple converter that can take something like a CSV and auto-generate metadata templates, a validation toolkit that you can check if you've covered the required fields. Some of these are still in development, but the idea is to take some of the heavy lifting off your plate. We're also working on community resources. So a template library for common study types, best practice examples, and step-by-step workflows. In fact, tomorrow, Jonathon will walk through one of those integration workflows live. Pretty exciting. And then the real power comes from, I think, community collaboration. So we've set up GitHub discussions where you can ask questions or share challenges. We'll evolve that schema based on how people use it, and we will want to encourage peer learning, because often the best examples, they're not going to come from the top. They're coming from researchers like you who've already figured out a very clever way to do something. So the message here isn't done and dusted. It's in progress. Come shape it with us. And so this is the landing page for the metadata schema. I think John put the link in the chat. And think of this as our starting hub. Here you can download the templates, either a simple CSV or the full JSON schema or XML, depending on what you're looking for, and how technical you want to get. You can also validate your metadata, meaning you can paste what you've written and check whether it meets the required fields. And finally, you can browse examples, which again are synthetic, to see how others have documented their data sets. We'd love for those to stop being synthetic and being real. But the idea is you don't start from scratch. You build on work that's already being done. We also have the full field reference, and this is what it looks like. So each field has a short description, examples, and even guidelines. So for example, the title, very simple, field gives you the rules for how long it should be. The abstract shows what a good summary looks like. This makes the schema hopefully more practical. You don't just get abstract definitions, you get concrete instructions for filling it out. I wanted to dive in a little closer to look at one of the sections we added specifically for this community, decision support attributes. Here you can record use cases like evacuation planning, risk communication, infrastructure. You can also define how your data set links to others. Say through those FEMA zones or the census FIP codes that we saw in the mystery data set. This is about making sure your data set isn't just documented, but that it's connectable, which is very important, right? How is it connectable and ready to plug into broader workflows? This is just a screenshot of the validator tool. This is very simple, but here's where you can paste in your metadata or upload a CSV file or a JSON, and it checks whether you've met the minimum requirements. And so we can think about this as like a spell check, but for metadata. It doesn't make judgments about your science. It's not super sophisticated, but it does tell you whether you've included the key information that others will need to be able to reuse your data set. And this is what that output looks like. So you can see it's just a checklist of all the required fields with green checks if you've nailed them, or warnings if something's missing. So in this case, we see that everything passes, but the validator also suggests a recommended field. Is there a license for this that you're aware of? And this kind of feedback keeps the process consistent without feeling hopefully too overwhelming. Here's just an example of what it looks like when you have a missing field required. And so the last piece here is community. And I think there's a lot of ways to approach that, but we've set up GitHub discussions as a space where you can ask questions, share challenges, and see how others are approaching metadata. And this is really where the evolution of the schema happens, right? So your use cases and user feedback directly shape that next version. And if someone forks it and wants to make their own version, that's very specific for what they're working on. But it's also where peer learning can happen. No one has to figure this out alone. So let's take a minute to step back and talk about that bigger picture. So metadata, as we saw, is like more than just documentation. And for us in social science, it's the difference between a data set that just sits on a hard drive somewhere and one that becomes a resource that others can discover, understand, and integrate into their own work. So when we have good metadata, practitioners can discover your work and know it exists. It enables integration, like we'll see tomorrow, where you can actually line up social data with weather data in meaningful ways. It fosters collaboration across disciplinary boundaries. You could find someone's data set, maybe you want to work with them and ask a different research question or a new one together. And very importantly, I think it amplifies the impact, right? So moving research faster into operational application. So the point here is metadata makes your research searchable, right? Far more discoverable, accessible, and actionable. So where do we go from here? So this is really just the beginning, right? So we drafted a schema, built some very lightweight tools, and tested the ideas with a handful of colleagues. But the real work starts when the community engages. So we need user experiences to shape all of this, right? What fields are missing from the schema? What is actually useful in practice versus what just sounds nice in theory? And importantly, how do we make metadata creation part of the workflow without adding overhead? And how do we plan for that? And so there are, a few ways to stay connected in all of this. I think that GitHub repo is where everything lives. That discussion space is open. So if you wanted to hop in today and start sharing ideas, challenges, or any feedback, go for it. It's there, open and live. And when we start thinking about tomorrow, we can start with today. Excuse me. So today was about the why, right? The why metadata matters, what problems it helps us solve, and how a schema, a shared schema, can give us a path forward. Tomorrow with Jonathon, you're going to pivot to the how. So once you know that integration is possible, the next bottleneck is actually doing it, right? So tomorrow's session is hands-on. You're going to work with real data sets, no more synthetic. You're going to demonstrate different combination workflows and show you how these practical tools for making this kind of integration reproducible. So in other words, today we built that foundation, and tomorrow we're going to put it in practice. And with that, I thank all of you for attending, and I believe I hand this back to Alison.
Thanks so much for the presentation and walking us through all of the dimensions of thinking in that particular in this particular space. We do have some time, so I would like to open it up. If folks have questions in the chat that they would like us to address while we still have some time available, we'd be happy to hang on and engage with you in that way. Chat looks relatively quiet.
I would also like to add,
go ahead, John.
If anyone had any issues with the binder or the Google Colab, let us know, and we can get those maybe addressed by tomorrow. Binder can be a little glitchy sometimes. The Google Colab is much better. You won't have experience any issues, but it will look differently than the Jupyter notebook that opens up in Binder. Google Colab does not support the same sort of markdown features that Jupyter does. So it'll look a little different, and if that was an issue, let us know. And you need a Google account. That's another good one, yeah. But we do provide I'm sorry, we keep talking at the same time. We do provide the HTML render, so you can easily follow through if you don't want to run it. And you can run it on your own time. They are downloadable, and we encourage you to download them and run them at your leisure as well.
Sure. And Jocelyn, thanks for that thought. I would say, we look forward to you joining us again tomorrow, where we put this into practice with John. Andrew, I see your chat here. So there is a question. Are there steps we could take to make metadata a yes and gently nudging people towards other researchers instead of just picking up new data sets and using them? Kyle, do you have thoughts on Andrea's question?
I mean, I think that is all about developing those shared social norms about contacting people, and that we should probably have a people first, researcher first approach versus data sets. But I think that it needs to be defined and agreed on. But no, I love that. That's absolutely the way to actually do collaboration and convergence.
See, Jocelyn has a question. The schema looks really great. Curious if you considered adding a space for limitations or way the data should perhaps not be used.
You know, at the top of my head, I think that there is in the quality section in uncertainties, there's a space to provide that. And then anything that isn't there, I think the assumption is that would go into the abstract and uses. But that's a really great point. No limitations and uncertainties for sure.
And it might have been you, Jocelyn, who earlier on had mentioned they would like to know about the sampling method, which I think would go under here. And I think, Kyle pointed out where that might go. And this was always when I was teaching undergraduates, this is always a big bugaboo for me, was I never knew enough about the sampling method and limitations. And so when you're doing your metadata and putting it in, err on the side of verbosity, right? Tell the story too much, because it's super helpful for those who want to use your data to understand, how it was collected, what are the limitations of that, what was the sample size, what was the sampling frame, all those various decisions that you made to collect that data, so then that person can know better about how and whether to use it.
I feel like the last time I said the chat's quiet. We had questions pop up. Thanks, John, for putting in any other comments from folks before we close for today. And if for some reason we don't get to your question and we end up closing before you maybe had a chance to finish typing it, by all means, we'll be happy to address questions tomorrow too. So please, no worries there. We're very much looking forward to tomorrow. All right, everyone, I will bring us to a close and thank everybody for joining. And we look forward to reconvening with a number of you tomorrow for part 2. Thanks once again and have a great day.